Hello, and welcome to the second lecture in critical thinking. It's me, John, and here is what we're going to be talking about today. I'm going to give you a broad overview of cognition, basically how you think. This will be useful for going forward. It's always a good idea to understand the sort of tools you're working with to see where they can be improved and see what sort of value they already offer you. So that's basically what we'll be talking about today. In particular, in these little subcomponents. Of course, the first is meditation. For that one, I'm going to direct you to the video on Leaves on a Stream. And just listen to that for a second, a little more than a second. Then come back and, with your mind calm and at ease and present, listen to me talk about the rest of these things. For instance, attention. So, look, we're going to be talking about cognition for a person at a time. This is not, exhaustive of say, you. You are a thing that exists over time, not just at a time. You're also a member in a group, like you acquire, or you, in fact, are a member of lots of groups, and there are, sorts of logical relationships that we will examine with respect to you and the group, but not today. We'll cover that shortly, though. Also, groups over time, so they're like, it's basically like a fourfold sort of way of thinking about things. You at a time, you over time, you as a member of a group at a time, and you as a member of a group over time. Again, today we'll just be focusing on you at a time, but don't worry, more anon. So, first thing for here, I want to focus on attention. This is crucial. This is like the upstream important starting point for thinking, I believe. So, look, we're surrounded by a booming and buzzing manifold. Like, we see perceptual stimuli, or we see, hear, feel things all the time. We can't, take it all in. There's just too much. We ultimately have to restrict our attention to some parts of our manifold, whether it's visual, auditory, etc. And when we do that, we start encoding information, either intentionally or unintentionally. Now, when we do restrict our attention, we exclude things. Like this is just basically what restriction means when it comes to attention. So that shouldn't be surprising. But this is not to say that while we're attending to one thing, we're not getting information about things we're not attending to. So think about this. Suppose I'm looking for cufflinks before I leave for a show. Honestly, I don't even have cufflinks. I don't know why I use this example. But suppose I'm looking for them in my drawer before I go to a show, and I don't find them. But then later on the drive, I realized that I actually did see them. I just didn't notice I saw them, and they were in the corner of the drawer. I just didn't it didn't occur to me while I was searching that they were in the corner of the drawer, but they were in fact in the corner of the drawer. This seems like just a sort of run-of-the-mill normal phenomena, right? Even when we're not paying attention, this illustrates we're nevertheless encoding information about the world, even if we don't see it, right? Even if we don't hear it, it's still getting in. And this sort of encoding can influence beliefs and desires you have without your awareness. Another thing to point out is that even at a time, and this is true of over time, but for right now, at a time, your perception is inflexible sometimes. Check this out. It's illusion, right? These two lines are the same length, but you kind of just look at them, right? You can't really see them as the same length, even though they're the same length. You know better, but nevertheless, your perception is not going to help you here. Artist MC Escher is famous for being famous about this, right? Playing with your perceptual illusions, or playing with these visual illusions. You can't help but to see something paradoxical. Part of this is due to us being pattern recognizers with our perceptual faculties. We look for patterns by disposition. We see patterns by disposition. In fact, it's useful for our evolutionary development, right? Our survival, in large part, I think, dependent on our ability to recognize patterns. Check all these faces out, right? In fact, you can search around on the web, but here's a good place to look for some patterns that you might see. Some funny, these two USB drives, for instance, are watching what appears to be an entertaining movie. I saw this on Our Faces in Things. So patterns. That's it. Like, we see them all the time. This happens not just with like perception, the hearing, seeing, etc., but also with our cognitive faculties. We look for patterns in our thinking as well. Abstract things like Watson and Crick received credit for discovering a pretty interesting pattern, the double helix structure of DNA. Watson like uncovered this, or sort of like realized this. He described it as a consolidation of data about the genome based on like a lot of images he'd seen, and then it like came to him as in a dream. Like, look at this beautiful structure, right? Actually, this the photos that he was using were taken by Rosalind. These are famous photos. This photo 51 in particular, it was shown. Well, they were the researchers who got credit for this were shown the photo without Rosalind's knowledge. Watson and others were awarded the Nobel Prize for discovering the structure of DNA, and she was not included among the recipients. Yay, patriarchy. Anyway, back to the thread. We're disposed to recognize patterns with our perceptual faculties and cognitive faculties, and sometimes these patterns are useful and sometimes not. Like faces in a cloud, not so much, but DNA, yeah, pretty important. In fact, we tend to be like over-generators of patterns or over-recognizers of patterns, and that's probably for the best. It's certainly useful when you're like a child and you touch like a hot stove to think, to make the inference or to make the pattern recognition or recognize a pattern that like all stoves are hot, at least for a little bit, because it keeps you safe, right? If you just went around and touched stoves, like hot or not, like you probably wouldn't survive very long. Like you'd be very damaged. But making the sort of like overgeneralization about the pattern is, in many cases, like useful for us. We can also undergenerate, like we don't see some patterns that are before us, and there are many reasons why we don't see patterns. We're going to talk about a lot of those later. But for now, I wanted to just sort of illustrate with a concrete example how this sort of pattern examining works, right? This is from a matrix, a Raven matrix test. It's like a generally used to test intelligence. And one of the crucial tenets, or one of the crucial features of this test, is your ability to recognize patterns. So I'll give you a second. Look at this. Which of the figures can be used to continue the series given below? If you want more time, go ahead and pause it now, but I'll walk through. It's this one. And check it out. Just, you're rotating, right? Rotating, right? That's the pattern. It's just a lot of, noise, but there's the pattern. I'll let you look at this one for a minute. Pause before, but it's the same setup. And there's the answer. Rotate. Do the mental rotation. You can see why that's the right answer. Now, we also should add to this sort of pattern recognition and this attention thing. We have limited working memory, short-term memory, long-term memory. Like memory is really useful insofar as it helps us like identify new patterns, uncover old patterns we've already seen, recognize things, digest new information in our perceptual manifold. But they are limited, right? Working memory is like what you can manipulate in your short-term memory, roughly speaking. And short-term memory is what you can hold for I think like up to 30 seconds in your memory. Long-term memory is this like encoding, longer-term encoding process. This is the stuff you have in your memory that you can remember when you were like a kid or something. Now, you already know some strategies for getting around these perceptual attention memory limitations. But let me draw your attention to one of them. Rather than attempt to memorize everything, for instance, we name things. And we name parts of things too, and we do this so that we can refer to them later. It's powerful. It's easy to communicate Fido, it's easier to communicate Fido to convey information about a dog than to try to describe the dog otherwise. You could describe its legs, its tail, etc. But like Fido, if I say Fido, you know what I'm talking about. It's that dog over there. This is especially true if Fido is a pretty basic dog. Basic dog. Hashtag basic dog. Just a plug. Anyway, naming is a divide and conquer strategy. It's useful for entities like us with limited memory, limited faculties. It does allow us to break down complex info into digestible parts. And this sort of approach, this like divide and conquer strategy, is not just used in naming, although in it's sort of used in labeling. I guess naming and labeling about the same thing. But you can see this generalized in perhaps surprising ways, ways that you might be more familiar with, like the grid method in painting, right? Or paint by numbers. So most of you are art students, so you're probably more familiar with this. I'm more familiar with this paint by numbers thing. But in any event, the labeling, it helps you digest complex information and divide and conquer all this stuff, right? Like divide and conquer this stuff and break it down into easier parts that you can use to then later cobble together, make a more complicated whole. Now we do this cognitively, we do this in practice, we do this by naming, we do this in all sorts of ways. This will be something we come back to because again, it comes up everywhere. But for now, let me jump over to another aspect of you at a time. This is conceptual hierarchies. Now, with these names, these terms we have, they're linked up to concepts that we have in our heads. Many of them we don't know where we got them from. Like, I don't know where I learned the concept dog. I just have it, right? But like, in any event, I have a name for it. There's a concept in my brain that corresponds to this, and it has a bunch of logical relationships to other names and other concepts, right? Like when I say dog, for instance, I know I mean mammal. Or when you hear me say dog, or when you hear someone say dog, you know they also mean a mammal because all dogs are mammals, right? This is like a taxonomy or hierarchy that we bring with us, and this happens all over the place. Like dogs are usually pets too. Like there's a hierarchy associated with dogs in that respect. Of course, not all mammals are pets, right? So there's some like disconnect, but still, you can see logical relationships. Connotations and stuff like that. In terms, like almost every concept you have or term corresponding to that concept is going to have some sort of logical relationship like this. Here's a very simplified version. A dog's a mammal, so is a horse. Bulldog's a type of dog, etc. These conceptual hierarchies, they sort of like are the underpinnings, I think, for your beliefs and desires. They're like the inputs. So if you tend to like a portion of your perceptual manifold, coupled with named parts of that manifold, you have this conceptual hierarchies in your brain, like logical relationships among all these concepts and names corresponding to them. These things inform your beliefs and desires, and they form hierarchies too. I use philosopher Quine's terminology here, although he didn't use interconnected. He talked about like webs of belief that are informed by these conceptual hierarchies. Now, I'm going to expand it because I think the sorts of webs are interconnected in various ways that he wasn't interested in pursuing. But also there is a web of desire. And I think it's just as easy to illustrate. So check this out. You likely believe that 2 + 2 = 4. Cool. Yeah, you got a conceptual hierarchy underpinning this, and you have it supports a belief that you have, namely the belief that 2 + 2 = 4. You also probably believe I'm bald, or am I? JK. But look, if you were forced to disbelieve one of those, it'd be easier to disbelieve that I'm bald. Perhaps I'm using a tricky camera or wearing one of my mother's wigs, which I was doing a moment ago. So it's, roughly speaking, just easier to disbelieve that I'm bald. Maybe there's like something went wrong. But like if you had to disbelieve 2 + 2 = 4, a lot of other stuff would have to go too, right? Like a lot of things you thought you knew about the world would change. Not so much with disbelieving that I'm bald. Like this is sort of like you can think of it as on the outskirts of the web. And the closer you are to the edge of the web, the easier your belief is to get rid of. 2 + 2 = 4 is like near the center of the web, and it has like all these ramifications for changing it, right? Like, and it would reverberate through the web. It would like vibrate all the strings, or the strings of the web, and they would have to change. And this is what I mean by like interconnected, embedded, like beliefs are embedded in other beliefs in this like interconnected web. Same with desires. Like you desire to live, no longer desiring that would require changing a lot. If you had like but if you contrasted this with like no longer wanting to eat peaches, right? Like that would not really affect too much of your other desires, right? Again, these are just illustrative that beliefs and desires are both embedded. Now, these beliefs and desires, these webs, they inform your behavior. I mean, that's how we operate. Like, you want water because why? You desire, or you believe this water is water, it's drinkable water, and you don't want to be thirsty, and you are, right? Like, that's a belief and desire sort of like interacting, and they output in behavior. And that is where I will stop today.